All right, let's do another example. So here, we've got this polynomial. So let's use the rational zeros, the possible rational zeros theorem. And so let's say we've got p. The p's are going to be the factors of 3, so plus or minus 1, plus or minus 3. And then we've got q, which is plus or minus 1. So in this case, our p over q candidates, our rational zeros, possible rational candidates, or rational zeros candidates are going to be plus or minus 1 and plus or minus 3. Now let's see if they work. So let's do plus or minus 1. Again, start with the easier ones to check. So let's test 1. So this will give us 1, minus 2 is minus 1, and then minus 3 is minus 4. So that didn't add up to 0, so that doesn't work. Let's try negative 1. Negative 1, this will give us 1. Here, this will give us negative 2, so negative 1, and then minus 3, so it gives us the same value. So plus or minus 1 did not work, so that's gone. So these did not work. Okay. What about 3? Well, 3 will give us what? 81 minus 8 minus 3. Definitely not equal to 0. Okay, so that didn't work. Okay, what about negative 3? It's going to give us the same answer, right? So 81 minus, oh, hold on a second. I got to do I was thinking 2's. Hold on. It's still not going to give us the right answer. So let's do positive 3 because I want to make sure I get the right number. So 3, this will be 81 minus 18. That should have been 18 minus 3, but still does not add up to 0. If we do negative 3, it's going to give us the same answer because the exponents are all even. So this is going to give us 81 minus 18 minus 3. Okay, so now in this case here, none of our candidates for being a rational zero worked, which means there are no rational zeros. But we're not done because remember our toolbox. This actually fits one of the things we've talked about before. It is quadratic in form, right? There's this exponent is double this exponent. As soon as we see that, we can write this quadratic in form, which means I could write this, I could say, okay, let y equal x squared. Which means I can write this as y squared minus 2y minus 3. And now I can factor this, okay? Because now I can find two factors of negative 3 that add to negative 2, which is going to be 1 and negative 3, okay? So that means I can write this as y minus, or y plus 1 and y minus 3. And again, you could test by factoring it out. You'll get y squared plus y minus 3y, which will give you the minus 2y, and then minus 3. Okay, but we're not done because we've got to put everything back in terms of x. So now I'm going to back substitute here. So this will actually end up being x squared plus 1 times x squared minus 3. Okay, now 1 is a sum of two squares. You can see it as a sum of two squares, right? And the other one is the difference of two squares. Okay, so this will factor into x, what? X plus the square root of 3 and x minus the square root of 3. This one is the sum of two squares, which actually will have imaginary roots. Okay, and this will actually, you can factor as x plus I and x minus I. Okay, that's it.